If the thickness of a human hair is around 80,000 to 100,000 nanometers, then imagine how incredibly tiny a single nanometer really is. At this nanoscale, DNA, proteins, atoms, and molecules exist. In other words, this is the level where the fundamental structure of life is formed, and nanotechnology works directly with matter at this scale. To understand the depth of the nanoscale, the next question naturally arises. What exactly is nanotechnology? Nanotechnology is the combination of science and engineering in which matter is understood, manipulated, and controlled at a scale of 1 to 100 nanometers. Through this manipulation, entirely new materials and systems created whose properties become completely different. Here, it is not just about making something smaller. As matter reaches the nanoscale, its entire behavior begins to change. Its physical properties like strength and conductivity, and even its biological interactions, can become completely different. Nanotechnology mainly works through two approaches. The first is the top-down approach, where a larger material is gradually cut, carved, or patterned down to the nanoscale. The second is the bottom-up approach, where atoms and molecules are directly assembled together to create entirely new structures. In the same way, nature builds everything from DNA to the human body. That is why nanotechnology is often called nature-inspired engineering, because for the first time humans are working directly at the level where the entire physical world begins. Now we enter a world where the laws of science no longer behave the way we experience them in everyday life, because the nano world follows its own unique rules. As soon as a material reaches the nanoscale, its surface area suddenly increases enormously. This means that most of its atoms are now exposed on the surface and constantly interacting with the outside world. Because of this, nanomaterials become far more reactive than materials of ordinary size. At the same time, quantum effects also begin to dominate, where electrons behave neither completely like particles nor entirely like waves, but instead follow a probabilistic behavior. And this is the reason why, at the nanoscale, the color, electrical conductivity, magnetic behavior, and even the mechanical strength of materials can completely change. For example, gold, which normally appears yellow in its larger form, can appear red, blue, or even purple as nanogold. Similarly, carbon, which seems weak in the form of coal, can become many times stronger than steel when transformed into carbon nanotubes. In this world, being smaller is not a weakness but the greatest strength of all, because anyone who gains control at this level gains the power to change the fundamental nature of matter. Thanks for watching this video. For more science-related videos, subscribe now.